number 1 we did in class together. So this is a straight line, meaning that it's moving at a constant speed. Okay, if you have a curve like we see in all of the other problems, that means that it's speeding up or slowing down. And that's when we're just talking about a position and time graph. So here we have a straight line, so that indicates a constant speed. It is in a positive direction because the slope is positive. So the description of motion, constant speed to the right. You know, we say that right is positive and left is negative. And then here we change direction because we changed slope. We went from a positive slope to a negative slope. So that means that now we're actually moving faster to the left. Here I tried my best to draw some arrows in the same size moving to the right, and then arrows that are bigger moving to the left. Please remember that you do not need acceleration vectors when your speed is constant. For your velocity, when you have a constant speed, that means your velocity doesn't change. So let's give this some arbitrary number here, like 10 meters per second. Then that means after some time, I'm moving 10 meters per second. After some more time, I'm moving 10 meters per second. After some more time, I'm moving 10 meters per second. My speed doesn't change. That's the point of being constant. So our velocity graph has to be at that same number for all time. Now, when we get a negative velocity here, that means my velocity is going to come to the negative region, and now we're moving to the left a little faster, so we have to be farther away from 0. At no time is there acceleration, so my acceleration is going to be on 0, and that should be a flat line, but drawing on the computer is a little tricky for me. Number 2, speeding up to the right. The slope is increasing, which tells us that it's getting faster, and it is moving in a positive direction, so that tells us that it's moving to the right. Now, when you want to show that something's moving to the right, the arrows have to get longer, and your acceleration vectors go in the same direction as your velocity vectors. So the velocity vectors here, we can see, are getting longer, and then I've just drawn some acceleration vectors here with each point. And they should be arrows. Your arrows should be much neater than mine because I'm writing on a computer. Now, I have to show that I'm speeding up to the right, guys, because we are moving to the right. That tells me that my velocity is positive, so I shouldn't have anything in this negative region. I'm going to start with a low speed and increase. That means we go away from 0. Now, to get my acceleration from my velocity, you have to look at the slope of your velocity graph. So when I look at this graph, this is a positive slope, so I have a positive constant acceleration. Number 3, we are speeding up to the left. Since we are speeding up to the left, my arrows have to point to the left and they have to get bigger, and when you speed up, your acceleration goes in the same direction, so I also have acceleration vectors pointing to the left. Now, when you speed up, you have to go away from 0. Since we're speeding up in a negative direction, I need my velocity line to go away from 0 or get more negative over time. Acceleration, this is a negative slope, so we're going to have a negative acceleration. See. Alright, number 4. Here we are slowing down to the right. I know we're slowing down because the slope is leveling out. It's not quite as steep. Imagine if this was a hill, this would be very steep, and then it gets less steep as you go on. So that means that you start out moving fast, and then you start to slow down. So we're slowing down to the right because this is a positive slope. So my arrows have to get smaller as I go to the right, and then my acceleration vectors are going to go in the opposite direction. My velocity, because we're moving to the right, I have to be in the positive section for my velocity. And here I start with a positive slope, so I'm going to start with a positive velocity. And I level out or slow down, so that means I have to slowly approach 0 meters per second, just like your speedometer would go to 0 meters per second as you slow down. Here we have a negative slope, so we have a negative acceleration, which is constant. Now, number 5, this section here, my position does not change. When your position isn't changing, that means you're not moving. And then we start to speed up to the right. Again, this slope gets steeper, so I'm going faster. It's positive, so I'm moving to the right. So my written description is not moving, then speeding up to the right. If you remember from last unit, to show that something isn't moving, we draw dots, and we just stack those dots on each other. And then to show speeding up, my arrows have to get bigger. And when we speed up, acceleration is in the same direction, so that's why I have acceleration vectors here pointing to the right. For the first section of time where we are not moving, we have no velocity, so there's a line here at 0, and then I start to speed up to the right, so I have to, in the positive region, leave 0 meters per second. Here where my velocity is 0, I have no acceleration, and when I speed up to the right, I have a positive acceleration because the slope of this line is positive. Okay, this guy, we're getting steeper. That means I'm moving faster, and it's positive, so I'm moving faster to the right. We're speeding up to the right. Then we move at a constant speed to the right. This is a straight line, so that's a constant speed. That's what we did last unit. Now, my motion map, I need to show that arrows get bigger for some time, and then they turn into the same size. So I just put little equivalent marks here to show that those arrows become the same size. Now, one thing that, you know, if you're picky, you can get into it. You don't have to. But this slope here is not quite as steep as what it was here. So actually, these arrows shouldn't be longer than the previous ones. But that's just semantics. If you made them longer, that's fine. And then here are acceleration vectors to the right, because when we speed up, acceleration vectors go in the same direction. Velocity. If I'm speeding up to the right, I have to leave 0 in the positive section. Then I have to move at a constant speed. That means I don't change my speed. Here for acceleration, we have to look at the slope of the velocity graph. This is a positive slope, so that means I'm going to have a positive acceleration. Here I have a 0 slope, so that means 0 acceleration. That line should be on 0. Alright, the last bit. So, description of the motion. This is a straight line, and it's positive, sloped, so that means I'm moving at a constant speed to the right. Now, my slope starts to level out a little bit, so that means that I'm slowing down, and it's still positive, so that means I'm slowing down to the right. To show that in a motion map, I'm going to draw a couple arrows to the right that are the same size to represent the constant speed portion. Then my arrows have to get smaller to show where I'm slowing down. When we slow down, our acceleration vectors go in the opposite direction. So here I've drawn 3 arrows in the opposite direction, indicating that I'm slowing down. My velocity graph, constant positive speed. So I'm going to have a constant velocity here. That means my velocity doesn't change. I don't go away from 0. That would mean that I'm speeding up, and I don't angle it towards 0 because that would mean I'm slowing down. This line is 0, guys. Okay, when we speed up, we go away from it. When we slow down, we go towards it. When we don't change, we don't do either of those things. We stay a flat line. Now I start to slow down, so from here I have to approach 0. Okay, now to get acceleration, we look at our velocity graph. There's no acceleration here. There's no acceleration vectors here, so my acceleration is at 0. Now if we look at this next section, this is a negative slope, so I have a negative acceleration. My arrows are to the left, so I have a negative acceleration. This right here, guys, I just want to remind you that this should be a straight line. I tried, but I'm not good at drawing on my computer. Number 8. Here we have a negative slope. That means I'm moving to the left, and it's a straight line, so I'm at a constant speed to the left. Now, this starts getting steeper. Imagine if this is a hill and you're walking on it. That's going to be steeper right here. So that means you're speeding up to the left because it's a negative slope. So I start here. I'm going to do a few arrows, 2 arrows to the left to show a constant speed, and then my arrows get bigger to show speeding up. And when you speed up, your acceleration is in the same direction, because remember, acceleration comes from forces. It's like something's pushing you. Something has to cause you to speed up, so we can imagine these acceleration vectors are helping us out. Now a negative velocity, I need to work in the negative region. This is a constant speed, so it's going to be flat. Now I have to speed up, so that means I have to go away from 0. In the beginning, I have no acceleration, so my acceleration is 0. And here we have a negative slope, arrows pointed to the left. Everything indicates that I should have a negative acceleration. And finally, number 9. Number 9 has 2 things going on. We're getting steeper, and then we're leveling out. So we're speeding up, and then we're slowing down. And all of this is positive, so that means we're always moving to the right. So on my motion map, I drew arrows getting bigger, and then arrows getting smaller. When they get bigger, your acceleration goes in the same direction. So when we're speeding up to the right, our acceleration vectors are to the right. When we slow down to the right, our acceleration vectors have to be in the opposite direction, to the left. Now, velocity. Speeding up to the right. That means I need to stay in the positive section and go away from 0. Now I need to slow down to the right. So I'm going to stay in the positive section and go towards 0. Finally, for acceleration, we have a positive slope, a positive acceleration. This should be a flat line. A negative slope and a negative acceleration. I hope this helps and prepares you for your quiz. Make sure you have all the right answers, and I will see you tomorrow.